Hi students, this is Mr. Yao. Today we're going to continue to work with algebraic properties. In this lesson, we are going to solve some simple exponential equations and see how we can justify the steps with the algebraic properties. But first, prior knowledge. Here are some exponent calculations that you should be able to do. So every single one of the next one, you're just multiplying by an extra 2 or 3. So let's see, 2 to the first power is a 2. 2 to the second power multiplied by a 2 is a 4, multiplied by another 2. So 2 to the third power is 8, 2 to the fourth power is 16, 2 to the fifth power is 32, and 2 to the sixth power is a 64. And 3 to the first power is 3, 3 to the second power is 9, 3 to the third power, so multiplied by another 3 is a 27, multiplied by another 3 is a 3 to the fourth power, which is 81, times another 3, 243, and times another 3, 729. So basically that means if let's say you have 3 to the x power equals 729, well this x has to be a 6th power because this is the only option. Okay, now let's have a look at a few solving equation problems. First, just like I was saying, 3 to the x power, well that means you have to rewrite 729 using a 3 base. So basically you can use your calculator to try 3 to the what power is going to give you 729. So 729 happens to be 3 to the 6th power. So we basically got 3 to the x power equals 3 to the 6th power. By one of the properties we have learned, which is equality property of exponentials, if the bases are the same, then the exponents has to be the same. So we just solve for that. X has to equal 6. Next, 4 to the x power, well, it equals to 16,384. So you need to figure out what is 16,384 if it has a base of 4. So you're going to try with your calculator, maybe 4 to the first power, 4 to the second power, and you keep trying until you get to 4 to the 7th power. That means 16,384 is 4 to the 7th power. So we copy down the left side. 4 to the x power is the same as 4 to the 7th power, so x has to equal 7. Because now they're the same base, the exponents would have to be the same. Next, same thing. This time is a base 5, even though the exponent looks a bit more complicated, but the base is still the same. So we're going to need to rewrite 625 using the base 5. And if you start trying with your calculator, you would see 5 to the 4th power is 625. 5 to the x plus 2 power is 5 to the 4th power. They already have the same base, which means the exponents has to be the same. So x plus 2 has to equal 4. And then we just solve that simple equation, subtract 2 on both sides. So x has to equal 2. D. It's a base 3, so now we need to figure out 3 to the what power is 6,561. So if you keep trying, well, you see 3 to the 6th power is 729, multiplied by another 3 is 3 to the 7th power, until you get to 3 to the 8th power, and that would actually be 6,561. So 3 to the 3x plus 2 power is 3 to the 8th power. They have the same base, which means the exponents has to be the same. So 3x plus 2 has to equal 8. Subtract 2 on both sides, 3x equals 6. Divide by 3 on both sides, x equals 2. And that's how we solve these simple exponential equations. Now let's justify some of the solving steps. Example 2, a very simple one. The first step is we are going to rewrite this 32 as 2 to the 5th power. So let's look for the change. The left side did not change. The equal sign did not change. We only changed the 32 to 2 to the 5th power. Now, 32 is 2 to the 5th power. So we are replacing 32 with something else that it equals to. So there you go. Substitution property. Okay. B, x equals 5. Well, now you see the bases are the same, and we just conclude that the exponents are the same. That there is a specific property for that. So it's equality property of exponentials. There you go. So that's a very specific, and it's a very quick thing. It only has 2 steps. The first step is substitution. You just replace the 32 with 2 to the 5th power. And as soon as they have the same bases, then you can just get rid of the bases and conclude that the exponents have to be the same. And that is the equality property of exponentials. Now example 3. Okay, this time is a little bit longer, but that's because the exponent is a bit more complicated. So first thing, you see the right side did not change, but the left side, 128 changed into 2 to the 7th power. Well, 128 is 2 to the 7th power, so we are just doing a simple substitution property because we're just replacing 128 with something else that it equals to, which is 2 to the 7th power. Next, as soon as we do that, you see they are the same base, so we can conclude about the exponents. 7 equals x plus 1. That is the equality property of exponentials. Then we're just solving this equation, and typically when you solve this equation, well, you gotta subtract the 1 to get rid of that 1. So there you go, subtract the 1 on both sides. When you subtract the same thing on both sides, that is going to be subtraction, POE. And then, if you remember the 3-step chunk that we have, POE is followed by inverse and substitution, and then is also followed by identity. So it's still the same thing here because the rest is just solving equation is just like our previous lesson. So as soon as you have the 1 together with the -1, that becomes a 0. And the 7 minus 1 is being replaced by something it equals to, which is a 6. That is the step that has additive inverse, not property, additive inverse, and substitution property. There we go. And as soon as you have the inverse and substitution, well, the next step is you see the 0 is gone, so additive identity. So here's our 3-step chunk. You're still having the 3-step chunk. Lastly, see the 6 went to the right side, the x came to the left side. So you're switching sides of an equation. So symmetric POE. And that's fairly quick. So the first 2 steps are pretty standard when you solve these exponential equations. You're substituting by rewriting the number with a new base, and then you're just getting rid of the base to conclude about the exponents. That is the equality property of exponentials. The rest are just like solving equations, the things that we have done in the previous lesson. So there's example 3, and that is everything for this 2.1c lesson. Thank you.